Magandang araw mga boss. So today may activity kami is about factory acceptance test ng chiller. So ito magiging parang hybrid siya kasi ang factory ngayon nandun sa Amerika. So hindi pwedeng pumunta doon kasi nga dahil sa condition ngayon. So ngayon hybrid na lang. So online na lang yung online yung factory acceptance test. Ayun, so maraming salamat nga pala sa mga nag-subscribe. So yung mga bago pa lang sa channel ko, ako nga pala si Engr Noel. So sa video sa channel natin meron tayong mga tutorial, tapos ganito mga testing at yung mga site visit. So kung bago ka sa channel ko, please subscribe at malaking tulong to sa akin. So maraming salamat. So ito yung setup. Online na lang ang testing.
Does that make sense?
Start na kami.
Okay, but we didn't receive any agenda that we can discuss.
I'm going to pull that up right now.
Please, thank you.
A lot of airflow going through there, of course, the ambient air temperature and so forth. We'll go to the next slide.
So ito nag-explain siya noon.
As it passes through the floor, you can see that little tape down on the bottom. I put a piece of tape to show you the air coming up through the floor. And as it comes up through the floor, it goes through those filter system, or what we call the heat exchanger, that you see immediately to the right of that piece of tape. That heat exchanger allows us to pass air through it. And of course, this is the exiting air from the unit. So that air is probably roughly 10 to 15 degrees hotter than your inlet temperature. And when it passes through that heat exchanger, we can now cool that air back down. So as it passes through here, I'm going to show you the next slide. So it passes through here, it goes to the outer side of the actual test chamber. And you can see those loops where the air comes back down through, cooled down, back to
Karoon na akong problema. Yung pinapresent lang data mataas yung sa selected na cooling capacity ng unit. So ayan, medyo kagulo. Pero hirap pag online.
Yeah.
So ito, ang naging problema is yung design requirement namin is mas mababa kaysa ron sa pinapresent nilang chiller unit. So ngayon, ang problema ngayon kasi yun sa size ng transformer namin, then medyo malaking discrepancy. So maapektuhan din yung mga protection natin, yung mga circuit breakers o yung transformer size. Kaya ngayon parang
very professional, and we could see everything, even small minute things also.
yes.
But we should, now we are not sure which model is testing and which model we approve. Right?
The model according to
According to the parameters and the things, we are getting different now. So for me, better first we should sort out all this, even if you delay 10 days, 20 days, 30 days, doesn't matter. But what we should make fair should be the thing which we approve actually.
Yes.
You should have, on your check, you should have the
yes, receive that.
Ayan, galit na yung coordinate. Dapat dito pakita na lang yung unit eh. Ba't di na lang pakita yung unit?
Now we're on the opposite end where we originally started from.
Ayan,
And you can
mag-start na
see
yung
the grate, this is the grate where the air
pot ng
goes
chiller.
up from the chiller into the air handlers upstairs where we can change the temperature. Can you guys hear me okay?
Okay.
Okay.
Yes, we can hear
Okay.
you. Thank you.
You're welcome. He's moving slowly around. We talked about those trees that were on the side of the chiller. I have some still pictures of that. And those are the trees that actually measure the entering air temperatures. So as that air passes through those, it collects the air temperature on both sides of the chiller. And the louvers you see there now is where the air is coming down from the heat exchanger upstairs, back in front of the trees there, and then it passes into inside the chiller where we can make the measurements. I'm gonna have them hold right here for a second. Mark, have them hold the camera right there. Okay, so essentially, you see that black hose as it comes down from the tree, it goes into a central container. We can hook as many as 3 trees to that. That helps make sure that the air is going through there on an even keel, and we don't have any interruption in as far as air passing through those holes. And he's going down toward the end of the chiller where we actually have the electrical hooked to. That is live power that's going into that chiller right now. So he's going to be a little careful, a little ginger around those wires. It is 3-phase voltage. Tom's not used to being in and around that. But we're going to make a technician out of them today. You guys can stop me at any time and I can have him pause the video.
Okay.
For now, you
This
can
is the
proceed.
this is the very end of the chiller where we look at our power connections, and of course where the display is or the control panel. Come to lift the camera up towards that display so you guys can see the front of that.
Can we see the plate also?
Actually, the air is moving that panel around a little bit. It's still mounted to the tripod. He was going to lift the tripod up so you guys can see the control panel and so forth.
Kita naman.
I told him not to get too close. I didn't want him to, create any, unwarranted safety issues. We good so far?
Okay.
Okay.
Yeah, so far it's okay. But if you can zoom the camera to the nameplate for the chiller, the description plate.
The control panel?
No, the plate where you have the model number of the chiller and the other details.
Oh, you want the actual serial number, the label on the chiller?
Exactly, yes.
Okay, hold on. I'll have him go back. Mark, can you hear me?
Ayan, pinacheck yung nameplate kasi kanina. Iba yung data na lumabas sa required, yung design requirement. Sa US
Mark, can
yung
you go
factory na yan.
over to the side of the starter? They want to see the nameplate, serial number, and model number.
Parang ano sa may panel.
It's a little warm in the room.
Ayun. Hindi ba ba? Can you take a photo?
You can see the nameplate, but I can't see the model and serial number. That's what they're interested in. See if we can get a little closer to it.
Can you take a photo and send on the chat box?
How's that, guys?
Okay. Capacity.
On the very top, serial number 12 indicates the week that it was built in. 21. That's good.
410.
I'm copy this right now. Hey, Mark, can you take a screen print and go ahead and send it to me? And I will, with Tom's help, we'll go ahead and put it up here on the screen.
Engineer Akil,
Any other readings you need?
can you show the ampere reading?
how do we know that?
Ampere reading. Ampere reading.
If all this compressor is running, how many compressor running?
And he will show us the next computer.
How?
Currently, how many compressor now?
Screen print, and then he's gonna put it on a stick for me, and then we'll bring it back upstairs to our city, and we'll go ahead and put it on the,
Okay, now the next point. Yeah, the next one is the other screen next to the water and air temperature.
Yep, those, the ones next, the screen next to it, and the other screen, is the operating controls that we use to operate the, system for the, for taking points. And, you probably could do a screen print of those as well, like, but it'll be a little easier for you guys to see. Would you like me to do that as well?
We need to have maximum from your side, so it will be easier for us here to release the approval and acceptance for the file.
Okay, so what you guys are seeing right now, this screen has, I showed you a picture of our support chillers. In about center lower is the support chillers that are operating and maintaining cold water. That helps maintain the air temperature that's coming through the heat exchanger back down to your chiller. The little box next to those two chillers or pictures of chillers, that's typically one of the screens that he goes to change the operating temperature. For example, if you wanted to go in and change your inlet water temperature, he would go into that box. He can raise or lower the temperature, and of course the values on the pneumatic controls will change the amount of water or air depending on what we're changing to satisfy that particular thing. Also on that screen, the lower right-hand side are the boilers that we use to maintain temperature for the cooler water. Again, that's also the same as a PID. If we want to change the temperature on that, we change it. The boilers will fluctuate depending on what we're running. Let's go to the very next.
Just a second. Also, we need to have the screenshot for that one also.
For the VIP.
Okay, I'll have, Mark, can you do a print screen on that screen I just described? If you don't mind, the one to the right or what was, yeah, that one. Can you do a print screen on that one as well?
And just make sure this Dropbox will not cover anything. Yes, okay.
Ano under na compressor?
Yep, we'll have to call that. Thomas, let's go to the far left screen. Now this is a picture of the actual chiller. What it shows is the two trees. You see it looks like a little black piping going to the trees. That maintains the, shows us what the temperature of the outside air temperature is coming in. And also the water flows on this one as well as the temperature. And I'll have Mark take a picture of that as well. So we'll put this all in that one report.
And how can we know that how many compressors is running, the 5 ampere?
How can we know that how many compressors are running?
As far as what is operating in the chiller,
Yeah.
or
No, the current situation.
right now, our support 30 series chillers are operating to maintain the temperature in the room, the air temperature. But on your chiller, there's two compressors. They're all running because it's running 100% load right now.
How can we? Can you show us on the screen
Three
that
compressors.
the two compressors or
Two.
the compressors of the chiller are running all of them? Is there any indication on the screen? This is one point, yes. And the second point also, we need the electrical data readings. Do you have any reading in the
1000.
computer now for the electrical data, the ampere, the kilowatt reading?
Small.
That kilowatt reading on the graph we're going to show you, there's a kilowatt reading there.
Separate.
That will show you the kilowatts on that,
The
the
micro.
power on that one.
Micro. This one is
That was the
128.
screen where it also shows the water temperature flows and all that stuff.
The ampere? It didn't show the ampere.
Can you show us the ampere now on the screen on the camera?
At 2 compressor running.
I'll bring Tom upstairs and we'll show you all those pictures.
Now running all
of the,
6.
3
2
computers.
circuits, 6 compressors.
And then, we'll go over that in a little more detail up here, we'll be able to see it better.
But now, only 2 compressor is running for this chiller.
4.
4.
6.
Oh, four running.
We go ahead and, we'll go over those 3 graphs. that we
And now
just
4
put.
is running.
Yeah, I think Tom's gonna put the camera back on the tripod, so it won't get dropped or kicked over. And then we'll go ahead and put these 3 pictures we just took on the screens in the operating room. We'll bring them in and we'll go over those if you like.
Still, we need to have the ampere reading for each phase. Do you have a clamp meter now? We can just witness it.
Yeah, do you want me to take a brief point on this chiller right now, like maybe 10 runs or whatever, or like 30, well, 10 runs would be about 5 minutes, and print out just another quick point to show you what it's doing right now?
Okay.
Would that be okay with you guys?
Okay.
But I can't get a closer, he put them side by side for some reason, he thought this was the best place.
We need to have
But,
clear reading for
I
those
can
2
blow these
screens.
up. He's put them on a Word document, but I can blow these up for you so you can see these numbers better before I send you that data. But this represents your chiller right here. These, of course, are the air temperature trees that we've seen earlier on the video and the still pictures that I took for you. Over here, of course, are the water flow meters and the temperatures both in and out. So that's important. This shows everything on the inside of the test chamber. This control screen that you see here is pretty much what he monitors. He'll go back and forth. If he needs to change boiler temperatures to get more temperatures on the chiller, he can go in and manipulate and change the temperature. This, he can also go in here and open and close pneumatic valves slightly to change the temperatures. This is pretty much all automated. He goes into the little block that will appear up in the screen, he makes the changes, the computer will go ahead and open and close slightly the valves that need to be, and that temperature takes place. But you're looking at, to run it from start and get it on point, maybe about an hour, hour and a half, for the whole medium of water throughout the test, through the chiller and throughout the system to actually settle and make sure everything's running in steady state. Any questions so far?
Can you show us in the previous graphs the efficiency?
Is there any?
Go up to check the efficiency.
10.07.
Say that again.
The chiller efficiency. On the graph, yes, here.
Okay, here's one. This was just taken,
It's like
10.07. And then this was taken at 8:15 to 8:30 our time in the morning, 10.02. And then 10.03 is what we measured. This is the graph that, from the actual test, that we looked at the data in the report. So it's pretty consistent, in the performance.
Just a second. We're
Double check mo yung data. What's the efficiency as per the data?
Mr. Thomas, efficiency you are asking.
the COPR.
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 This one also is efficiency, but this one you have to convert to this. Okay,
COPR.
Power consumption.
divided by 3.4 kilowatts.
This one. 1.9.
Without pump.
2.9. Very high, 2.9. This one is different, the same as COP. You have to divide it.
Yeah, the electrical to the cooling capacity.
Yeah, this
To see the efficiency.
the COP is kilowatt over kilowatt. I don't know, this ER maybe
Yeah, it's
BTO over like that.
consumption. It's
But still here, very high COP compared to your over. We will see in voltage.
Okay, now the next step, we need to have the electrical readings for each compressor, the ampere and kilowatt.
Do they have? Maybe they have.
Maybe on the monitor there.
Okay.
Is it available in the graph here? Because the graph is not clear.
Because they already
Okay.
calculated
You're looking for the actual
Actual reading.
readings of the compressor themselves.
Yeah. No data.
No data. No data there.
Me?
No data there from the mostly mechanical.
Yeah.
Yeah, this was mechanical.
Okay, we're gonna check with the lab to see if they can pull that data off the running machine right now. So Danny's on the radio and we'll check to see if he has the individual. Because the report that we show you shows total, of course.
For the individual that has to hook up some engineering equipment, shut down the filler to do all of that, and then restart and take that point. If that's something that you want me to do, I can do that, but it won't happen right now. It's gonna be a little while for us to do that. It might be even a thing where I could forward that information to you guys, email wise.
Well, total power.
Total.
Okay, can we have the total power?
I can have the technician, it takes a while to do that because we have to put on what we call Yokogawa reading. We have to measure the individual circuits. It can be done, but will probably be done tomorrow.
Let me tell you something. Tomorrow is our weekend and it cannot be done. I prefer that we finish everything now. We don't have time, you don't have time, but we don't have time again to redo the test. So if you can provide us with the total power consumption, the total load, please, we can finish it now.
In the monitor, there's no reading there.
Can you show us in the monitor what is the reading for the kilowatt that you show us at the beginning, 235 or 135?
135.9.
All right, hold on.
Okay.
But they have that one in
Yeah,
there.
yeah.
You have ER. This was the reading.
Mr. Thomas.
Power.
Through ER they can find out.
No, ER is there.
You have to show
How
how
can
he
you
can
get
calculate.
ER
Yeah, I can manually
power?
calculate.
You can calculate that,
Okay.
but they don't see the readings.
All right, this is the original screen we had, this is the original performance from 8:15 this morning. Here's the power. Of course, here's your voltage, your KW power.
There.
Yeah, this
Yes,
is
that's what we need.
135.93.
The KW. Now here you are showing 135.93 actual. Can you show us this reading from your computer, your BMS system, from the control panel, by any device? Now.
I think they have that.
No, this only measures the total power of the whole chiller, so.
Oh, yeah, okay, this is enough for us, if you can show us the reading.
Just show us the reading from the equipment.
Show us the reading from the equipment or from your software.
The software.
I mean the graph. If it's available in the graph, then it will do the work.
I think, yeah.
The technician says it's not on the front of your, screen, the touchpad, your control panel on the chiller itself, he said it's not on there. This would be something we would have to, go back put on, extra measuring equipment, power equipment meter on each individual
In
circuit.
the control
and then
panel,
measure.
there's no reading for the power.
This takes time,
Ampere?
would be
How
till
do
tomorrow
they
before
get
we can do
the
that.
Thomas?
How do they get the
Daniel.
Can you ask?
Mr. Daniel.
ERs.
Yeah, what's the formula of the
Cooling the capacity of
Power.
consumption.
Yeah, then how can you get the accuracy? You have an input there in your
Okay, this is my situation.
Do you have input?
They don't have the voltmeter there to measure the actual voltage input. They don't have the voltmeter, the multimeter. I think that's a common tools in the factory.
I think they have.
I'm going to, yeah, Mohammed, I'm going to go ahead. You just took another point, so I have that data here. I'll pull it up.
Okay. Okay, let's discuss something here. I just put mute.
But I don't know. And they have a feed because their software will automatically calculate the EER. And
Yes.
this EER needs the total power.
Yeah,
So they have a feed power from this one going to the.
I have you at mute.
This is Daniel, right? Or Thomas?
Yes, we're here.
Okay. Now, mechanical side is okay for now. We need only the electrical. The electrical panel or the control panel on the chiller itself. Can you show us the readings on the panel itself? Somebody will go up and just press the buttons and show us the kilowatt, the amps, the each line power, frequency.
Voltage.
Voltage.
Exactly.
You want those readings from the chiller as it's running right now?
Exactly, yes. While it is running.
Okay. He's called the technician.
Tetes na nila.
84 kilowatt.
No, no, no.
No, what?
Here there is point.
See?
So here this is
28.
28,490. Okay?
28 kilowatts.
Then we have here 69 kilowatt, 107 kilowatt, 28 kilowatts.
What's that per compressor?
Not
Yeah, per compressor. Per
Mm.
compressor.
Yes, per compressor. Yes.
And here the amps also per compressor. 3 compressors per circuit. This is circuit 1 and this is circuit 2. This is the amp for each one.
ABC, ABC, ABC.
Yeah, 1, 2, 3. A1, B1, C1, A2, B2, C2.
ABC. Yeah.
Meron sila eh.
Yeah. 2, 6.
But one thing, number 2, Abdullah,
Yes.
this is unit TOT BC1. This is 284.
How many amps?
No, no, no. This is 28,490. Ah, sorry.
Okay. 28 kilowatt means?
No,
Where are you reading?
Here.
Which
column is this?
Second, yeah, this.
This is 28,490 watt. So 28 kilowatt.
28
The ABC is the phase. ABC is the phase.
Yes, it's a phase. It's a phase.
Okay, okay. Most in the range.
What is our
And this is the total. This is the total. Unit watts total 136 kilowatt.
kilowatts?
Yeah, this is the total.
Unit watt
And
total.
unit watt total.
136.332.
Yes.
What is our
AB1, BC1.
Engineer Abdallah? What's the size of our breaker?
320.
320.
Yeah, it is 400 adjusted to 320 as per Al-Fanar selection.
Okay.
It's a 400 ampere adjusted to 320.
Okay.
Any other points? Mechanical, electrical?
This is okay.
So all within the limits.
Within limit.
Yeah, within limits.
But the voltage is 420. If our system voltage is 400, the ampere will increase. But I think anyway it will.
If you check here, this is the power factor. This is a little bit low as per them, but we can just raise it up.
Okay, now So far, it's okay. We need from your side the nameplate picture. No videos. We don't need any videos now. We need nameplate picture. We need all around the chiller pictures for the current situation, for the file. We need the props pictures. We need the piping, the return louver above the chiller, and we need the flow meter picture. The one you said that it's above and camera cannot reach there. We need only pictures. We need to file each and everything in the file. We need to record everything. And all the readings you show us, all the documents you show us, we need everything from your side.
Okay, so do you need that today, or do you want that to be part of the overall?
Take your time. If,
report?
you can arrange by tomorrow from your side. The code number, model number.
Ayun mga boss, tapos
And I
na.
check also the serial number.
Uwian na kami.
We didn't take the picture by ourselves.
I'm a witness.
In and out. There's a calibration.
Ayan. Consolidation ng mga comments sa mga part. So, natapos.